So here was our answer for part A on question 18 from mixed exercise 7. Now part B, I'm starting in a new video because I suspect this is the one that's causing the problem. Now when you approach this afresh, okay, express this thing in the form of this. Now in part A, we have a standard method for doing this. When we see r sine 2x plus alpha, it looks enough like r sine theta plus alpha that we can use a standard method. Now here though, we don't have a standard method. So we're going to have to look at it and we're going to look for clues. Now, this is the thing we're trying to change, and we're trying to change it into this form. And I'm noticing that I've got an x here and I've got a 2x here. And I'm then noticing that I've got a sine cos here and I've got a cos squared here. Now, when I think of sine 2x, I know that's 2 sine x cos x. And when I think of cos 2x, I know that is cos squared minus sine squared. And I know that a sine squared can turn into a cos squared. So I'm thinking the way to do this is to use the double angle formulae on this expression here, and then equate the coefficients from this term, from this expression and this expression, and see if we can go from there. So a sine 2x plus b cos 2x plus c, I'm going to write as a times 2 sine x cos x plus b times cos squared x minus sine squared x. So, I would have b times cos squared minus sine squared, but I'm going to write that as b times cos squared minus b times sine squared x plus c. Now, the expression that I'm wanting to, I'm trying to rewrite this as something with a sine cos and a cos squared in it. So I'm going to take my sine squared and rewrite that bit. So leave this lot all alone. And I'm going to write sine squared like that. Cos x plus, we're going to have a minus b, and we've got b times cos squared, and then that minus times that minus is going to be a positive, so 2b times cos squared x. Okay, so we've got 2a sine cos, b cos squared, and another b cos squared, and a minus b, and a plus c. So that thing there, the thing that we started with, can be rewritten like this. And they want us to express 3 sine x cos x plus 4 cos squared x in the form a sine 2x plus b cos 2x plus c. Little edit there while I confuse myself. Let's carry on from here. 3 sine x cos x plus 4 cos squared. They want us to write it in this form here, and this expression we can rewrite as this expression here. So I'm looking at this one and this one, and if I can find the value of a, b, and c from those two, from the fact that this is equal to this, then I can use those a's, b's, and c's to write it in this middle form here. Okay, so let's use the same trick we used in part A. Let's equate the coefficients. So 3, the coefficient of sine x cos x has got to be equal to the coefficient of sine x cos x. So equate coefficients, and we get 3 equals 2a. So that tells us that a equals 1.5. We get 4. This is the coefficient of cos squared here, and the coefficient of cos squared here is 2b, so that gives us b equals 2. And then I've got no constant here, so 0 is going to be equal to minus b plus c. So we already know that b equals 2, so just to spell it out, minus 2 plus c equals 0. In other words, c is going to equal 2 as well. Okay? So I know A, I know B, I know C. This expression can be written in this form with this A, B, and C. Okay, because this form here is the same as this form, and this is identically equal to this form, and these A's, B's, and C's are these A's, B's, and C's. All right, so the answer we're looking for is 1.5 sine 2x plus 2 cos 2x plus 2 is exactly the same as 3 sine x. Now you might think, well, why bother writing the whole thing out? We've dealt with this, but we're going to need this sort of visible clearly for part, sorry, that's a cos squared x, isn't it? For part C. Okay, so for part C, now you might not be surprised to be seeing this 1.5 and this 2 show up if you've already read ahead to part C. And maybe you are surprised. Let's have a look. The reason I wasn't surprised to see those numbers come out in that way was this. Hence is telling us from part A and B we can solve part C. Use your answer to part A, so using this, deduce the maximum value of this. Well, so that means that part A and part B must be linked. Now when I look at them, this is something times sine 2x plus something times cos 2x. So this is, the thing from part A is very similar to this from part B, but in part B we've got a constant added on. So I'm not too surprised to see that A and B turning out to be the same coefficients as they were, which is exactly what's happened. So find the maximum and minimum values. So in other words, this thing, 3 sine x cos x plus 4 cos squared x, is the same as, sorry, let's see, it should be a 2, shouldn't it? It's the same as that thing plus 2. And that thing, we know from part A, is 2.5 sine 2x plus 0.927. So 2.5 sine of 2x plus 0.927 is the same as this thing in this box here. So if I do that plus 2, that is the same as 3 sine x cos x plus 4 cos squared x. Okay, so now, what's the maximum value, maximum and minimum values of this? It's the same as the maximum and minimum values of this. And we're getting back into a slightly standard question. Writing things in this form, the r sine theta plus alpha form, one of the standard things they ask us to do with that is find the maximum and minimum values. So if you're not too confident, this is how it goes. These numbers in here would take the sine graph and make it stretch and slide in the x direction. So that doesn't affect the maximum and minimum values. Maximum and minimum values of sine theta are 1 and minus 1. Doing things inside the brackets doesn't affect them, but the 2.5 does. That takes the sine graph and stretches it up. So the maximum is at 2.5, the minimum is at minus 2.5, and then I've deliberately not drawn it hitting the x-axis in the right place because I know I've stretched it and slid it in some sort of way. I'm not bothered about the stretches and slides in the x direction, but in the y direction, we're now going up to 2.5 and down to minus 2.5. If I then add 2 on, that takes the whole thing and slides it up 2 spaces. So this 2.5 goes up to 4.5. This minus 2.5 goes up to minus 0.5. So the maximum and minimum values of this are the same as the maximum and minimum values of this. Maximum and minimum values of this are 4.5 and minus 0.5. Which hopefully is the answer in the back of the book as well. And let's just, I'll double check that. Well, I'll double check that when I stop the video. Hope that helps.